the mean. The mean, also typically, unfortunately, called the average. Formula for that, you just add up all the data values. And divide by number of data values. You'll see lots of different notation for this. The notation that the book will also sometimes use looks something like this. Okay. This notation means exactly what that top thing says. Okay. This funky E here is called a sigma. It's a Greek letter. Sigma is shorthand notation for add. The little x's here just represent the values of your data points. Okay. The n, as will almost always be the case in this class, n represents the number of data points that you have. Okay. So, data values. Pretty straightforward in calculating that. There's no tricks involved. Nope. Another way of thinking about what the mean is that if you were to use a dot plot, to graph your data, the mean is going to be the place in which you would put the little fulcrum, the little wedge, so that all of your data was balanced. So that's how you can interpret the mean in another way. Okay? The mean is sort of the balance point between our data. The median, we talked a little bit about this one in the past. The median is another way of describing the center of our data. It describes the center by listing the value that shows up in the exact middle if we were to list all of our data values out. Okay? So the median, bless you, thanks. Center point, the center value of our data, when it's listed or ordered from least to greatest or greatest to least. Now, sometimes when working with the median, it's not always easy to identify where that center point is. And let's take a look at an example of this real quick. Okay. Let's go ahead and find the mean and median of the following set of data. All right. Here we have 8 data values. We want to go ahead and we want to find the mean and the median of this collection of data points. Alright, so we'll do the median first because it's probably the easier of the two. It doesn't require us to get out our calculators or anything. To find the median, what we have to do is we have to order our values from least to greatest. Okay? So if we go ahead and do that, or we can go greatest to least, it doesn't matter. 88, 95, 103, next will be 110, 115 I think, 116, 116, 121, and then our 138. There's our data listed in order from least to greatest. Okay. Our median is supposed to be the one that's in the exact middle. So the median would be the one that shows exactly in the middle where half of my data is above and half of my data is below. Alright? So I have 8 values. 1, 2, 3, 4. 1, 2, 3, 4. My median should be right there. What data value shows up there? There is no number there. There's no number here. How can my median not be a number? There's no number for me to represent my median. Well, let's throw up our hands, let's go home. We can't find the median, let's quit. Right? Oh, let's not quit, come on. What we'll do here, in instances like this, where we have an even number of data values, what we're actually going to do is we're going to take the middle two, the two that show up on either side of where that median is supposed to exist. We're going to take those two values and we're going to find their mean. Okay? So our median is going to be the mean of the 110 and the 115, which if you calculate that, what do you get? 112.5. And so what this example indicates is that the median isn't necessarily going to be one of your data points. Okay? The median is not necessarily a value that showed up in the data you collected. Okay? Sometimes you have to construct a median based on the data you did collect. And in this case, that is our median. Okay? All right, so we have our median. What about our mean? If you were to find the mean here, what would you get? 110.75. Okay. The mean here, the overall mean, so this is our median. Our mean is 110.75. The book and most people that work with statistics on a regular basis like to find shorthand notation for this. The shorthand that you will find the book uses is they will typically use an X with a bar over it to represent the mean. Okay? So whenever you see an X with a bar over it, that always represents the sample mean. Okay? This means that you had a collection of sample data and you took the mean of it. Okay? So whenever you see that in the book or on a quiz or a test or anything, that's what that means. It's the sample mean. Let's take a look at some other aspects of the mean and median. Okay? The data we have over here, let's take it again and let's change it a little. Let's go ahead and add a single value to this collection of data. So we have our 110, 115, 103, 116, 121, 95, 138, 88. Someone else give me a number.
7.
Give me a, that's a good number, 7. We'll throw 7 into the mix now. Okay? Let's go ahead and let's calculate the median and the mean of this new collection of data. Okay? Well, the median shouldn't be too hard to that. Right? The median, all we're going to do is just going to tack the 7 onto this end. Tack the 7 on. Actually, we put our 7 here. What's our median now? Notice now our median is just going to jump into one of the values that we have here. In this case, our median becomes 110. All right. And now what happens to our mean? What do you think is going to happen to the mean? Before you actually calculate it, what do you think is going to happen?
It's going to drop.
It's going to drop. Is it going to drop just a little?
It's going to drop like a British nanny.
Like a British what?
British nanny.
Okay. It's going to drop like a British nanny. Okay. Term I've never heard, but that's okay. Go with it. All right. So if we calculate the mean here, it dropped. It didn't drop quite as far as the British nanny. It only went down to 99.2, but still dropped a reasonable amount compared to how far the median dropped. Okay. This behavior indicates that the mean is very temperamental. Okay? The mean does not like you to put in values that are really, really high or really, really small compared to the rest of the data. Okay? It changes a lot when you add or remove large values or very small values compared to the rest of your data. Okay? Because of that, the mean is what is called a non-resistant measure of center. Okay. The term non-resistant means that when I make a change to my data, when I make a change by adding or removing a data value, the mean is going to usually move a lot. Okay. So the mean is a non-resistant measure of center. The median, on the other hand, when I add a data value to my collection of data, when I add either a number that's really, really, really big or really, really, really small, the median doesn't care. The median doesn't care about what your numbers are. All the median cares about is how many values are there. If you added a value, great, you added a value. The median is just going to move up or down to the next value in your list. Okay. So the median is what is called a resistant measure of center. As we progress through the course, you'll find that there are other resistant and non-resistant summaries, data summaries, and that's something that we have to make sure that we're
Aware of?
Aware of. There you go. Thank you. It's something that we have to make sure we're aware of when we're looking at data that we're working with. All right. Now, we've seen sort of what happens analytically. When we plug numbers in, we can see what happens analytically here. What about graphically? What kind of things can we say graphically in relations to being in the center with our distributions? So you remember last time we talked about 3 different types of distribution shapes. We talked about symmetric distributions, we talked about skewed left distributions, and we talked about skewed right distributions. Okay. When we look at these, when we look sort of at a symmetric distribution, with a symmetric distribution like this, where is the median of this data? The top, the place where the line of symmetry occurs, where this thing can be folded over. This is where our median shows up. Okay? All right. What about the mean? Where do you think the mean is for this collection of data? It's actually in the exact same place. When we have symmetric data, the mean and the median are almost always equal, and they occur, if they're not exactly equal, they occur very close to each other. Okay? So anytime we have symmetric data, our mean and our median are going to almost be identical. Okay? All right. Well, what about when we have skewed data? Suppose we have data which is skewed to the left or skewed to the right. What is the effect of the mean and the median there? Well, let's take a look at the picture and try to reason our way through it. Suppose we start with a skewed left. Okay. So if we look at skewed left. Okay. Skewed left. Now, the median, again, remember, the median sort of measures the exact center of where our data occurs. In this particular picture, where is that center going to occur? It's going to occur to the left of the big bump, but it's not going to be too far down here, right? Because we're still sort of measuring sort of half of the data on one side, half of the data on the other. So the median here is going to be somewhere around here. Not exactly right there, but somewhere around where our median is going to occur. Okay? All right, now let's think about the mean. Remember, the mean is this non-resistant measure of center. If we have a bunch of really, really small values, what's going to happen to the mean? It's going to get really, really small as well. It's going to tend towards those very, very small values. So when we're working with skewed left data, our median and our mean is going to occur to the left of our median, and it's going to be pulled in the same direction as the tail. Okay? So for our skewed left data, what we typically find, or what we almost always find, is that our mean is going to be less than our median. Okay? All right. Well, then if we change our picture around and go the other way, if we have a skewed right distribution, okay, For the skewed right distribution, our median, well, our median should still be sort of around where the big hump theta is.